All right, this is 8th grade, Module 1, Lesson 5 on negative exponents and the laws of exponents. All right, so what do we do when we come across an exponent and it's negative? Not the base number, the actual exponent itself is negative. So for instance here, some number to a negative exponent of some sort, what do we do when that happens? Well, technically, as you know, all numbers have a 1 underneath them. So by doing the opposite, moving it to the opposite location, which in this case would be the denominator, the exponent changes to its opposite. So the n is no longer negative, it becomes a positive by moving it to the denominator. And then just the opposite. If the number down here is negative, like so, moving it up cancels that negative as well. So you would just get rid of the fraction altogether and it would go back to its positive exponent position. All right, let's give these a try. Exercise 1 here. So they want us to take out x and b here and replace them with these numbers. So if I have 1 over x, which is 3, raised to the b power, which is negative 5. To make this a positive, I'm going to take it out of the fraction form and just make it 3 to the 5th power. So that's it. That's all you do. So we're going to say we flip to get a positive exponent. So you just kind of kick it out of that fraction form and do the opposite. So instead of it being under 1, we're going to put it over 1. And we typically don't write over 1, so it just becomes a whole number base. All right, let's look at this one. We have 3 times 10 to the negative 2nd power, all right, which is going to equal, the 3 is good, the 3 is positive, so that's going to stay on top. It's good. But the 10 is technically attached to that negative 2, so it needs to drop down here. And when I drop the 10 down here into the denominator section, that 2 just became positive. So now I can actually write this out as 3 over 100, because 10 to the 2nd power is 10 times 10, which gives me 100. And then I could even find the decimal form of that if I wanted to, and it's 0.03. All right, let's look at exercise 3. Exercise 3 says, what is the value of 3 times x to the negative 5th power? All right, so just like what we just did, the 3 is positive, so that's going to stay on the top. The 10 is attached to that negative exponent, so it needs to drop down here, but when I drop it down into the denominator, my exponent now became positive. All right, so this expanded out would be 3 over 100,000. And in decimal form is that. All right. Now, if you remember from our previous lesson, when we took out a number and we had to write it in exponential notation, our number didn't have any decimals in it. So now we have some decimals. You have to remember that anything after a decimal is considered a negative. All right? Anything before a decimal is a positive integer. So, just like we did the other day, I'm going to write this out, 4.728. All right, this time, your 4 is 0. And since we're going backwards, these are going to be negative. So, negative 1, negative 2, and negative 3. All right, so now let's write this all out. We're going to do the parentheses, and remember, it's always times 10. So, it's times 10 to the 0 power plus 7 times 10 to the negative first, and you don't need to include the decimal in here because the decimal would happen if you solve this all the way out. The decimal would fall right here because now you went from zeros and you're going into the negatives. That would require the decimal to go here because all these numbers are going to have a decimal. Plus 2 times 10 to the negative 2nd plus 8 times 10 to the negative 3rd. And that's it. All right. I'm going to let you try exercises 5 through 10. And then I will meet you back for exercise 11. Now, exercise 11 here says we accept that non-zero numbers x and y and all integers a and b. So these are the ones that we have practiced where we added the integers, we added the exponents here. We multiplied the exponents here. We distributed the exponent. Here we subtracted the exponent. Here we distributed the exponent. So a whole bunch of different scenarios. We've done all of these so far. So let's look at exercise 11. If you notice, they both have a 19. What am I going to do here? Well, I know I'm going to do 19 and then 2 minus 5. Now, as you know, 2 take away 5 would give me a negative exponent. So right now, we're just writing this out. But down the road, you would then solve this, and it would be 19 to the negative third power, which would give you 1 over 19 to the third power. So for right now, let's just write it out. All right. Let's look at exercise 12. We have 17, and then we have 16 take away a negative 3. All right, well, I see something here I need to fix. A negative and a negative become a positive. So this is actually 17 and 16 plus 3. All right, number 13, we're actually going to skip that one. I really didn't like that question. And we're going to go on to do 14. Now, 14 says, show directly that 7/5 raised to the negative fourth power would equal this answer. Well, the reason why is if we did x over y and we raised it to an a power, we get x to the a over y to the a. So this is what we call as a proof, because that's the definition of doing this. So this 4 goes to the 7, and the 4 goes to the 5. Now, if you really wanted to solve all this out, you would actually flip these. So that'd be 5 to the 4th over 7 to the 4th, giving you to get those exponents both positive. But they didn't want you to do all that. I'm just showing you the extra step. This is what they wanted you to do, was to prove it. All right, you were going to do the problem sets 1 through 4. And so that ends this video tutorial.